In the cold, silent darkness of deep space, far beyond the orbit of Mars, a visitor from another star system appears to be breathing. The interstellar object, known as 3I Atlas, is doing something that should be impossible. It is exhaling 40 kilograms of water vapor into the frozen void every single second. At this immense distance from the Sun, our own comets are dormant, frozen solid. This one is wide awake and active, and astronomers are faced with a profound and beautiful mystery that challenges everything we thought we knew about these celestial travelers. This is not just a strange comet. This is a signal from a different corner of the galaxy, a quiet and powerful anomaly that is rewriting the rules of the cosmos. If this exploration into the unknown captures your curiosity, consider supporting this channel with a gentle like and a subscription. It allows these independent deep dives to continue. Now, let us turn our minds to that distant point of light and the impossible river of water flowing from it. We will explore how we detected it, what it means, and the deep, silent questions it poses about the strange and varied worlds that exist beyond our own. The story begins in the freezing twilight of the outer solar system, in a region more than 3 times farther from the Sun than the Earth is. Out here, at a distance of over 3.5 astronomical units, more than 500 million kilometers from the Sun, sunlight is a faint and distant memory. It arrives with less than 1/10 of the intensity we feel on Earth. It is a place of profound cold, a realm where temperatures are so low that water ice is as hard and as inert as rock. The comets native to our own solar system, those dirty snowballs of ice and dust, are in deep hibernation at this distance. They are frozen, solid, inactive, patiently waiting to be drawn closer to the Sun's warmth before they begin to stir. This is what makes the observation of 3I Atlas so extraordinary. In early 2025, a space telescope called SWIFT, an instrument designed to hunt for the violent high-energy explosions of gamma-ray bursts, turned its sensitive ultraviolet eyes toward this faint, incoming interstellar visitor. And it saw something that, according to everything we know about our own comets, should not have been there. It detected a vast, shimmering halo of hydroxyl molecules surrounding the comet's nucleus. Hydroxyl, chemically known as OH, is a beautifully simple but profoundly significant molecule. It is a fragment, a piece left behind when a water molecule, H2O, is torn apart. And the only thing in this part of space with enough energy to do that on such a scale is the ultraviolet radiation from the sunday. The presence of a hydroxyl cloud around a comet is an unmistakable fingerprint. It is a smoking gun. It is the cosmic equivalent of seeing steam rise from a kettle. You know, without a doubt, that water is being heated somewhere nearby. When Swift's instruments saw that halo of hydroxyl, they were seeing the ghostly echo of water molecules that had, just moments before, been gushing off the surface of 3I Atlas. The science team behind the observation went to work, and the numbers they calculated were staggering. To produce a hydroxyl cloud of that size, at that distance, 3I Atlas had to be releasing 1.35 times 10 to the power of 27 water molecules every single second. It's a number so large it's difficult to picture, so let's translate it into something more tangible. That is the equivalent of 40 kilograms of water. Every second. Let that image settle in your mind for a moment. Imagine a small car. Now imagine its weight in water. 3I Atlas is expelling that much water into the vacuum of space every minute. It is not a gentle fizz or a subtle leak. It is a flood. It is a constant, powerful, and utterly mysterious outpouring from a frozen rock in a part of the solar system where water should be locked in a permanent, icy slumber. This behavior is what sets 3I Atlas so starkly apart from the other interstellar visitors we have seen. Let us remember them. Our first guest, Oumuamua, was a complete enigma of a different sort. As it passed through our system, Astronomers searched desperately for any sign of outgassing, any hint of a cometary tail. They found nothing. It was, as one astronomer famously put it, dry as a bone. It was a silent, tumbling, and inactive rock. Our second visitor, Tuai Borisov, was a more familiar sight. It was an active comet, and it put on a beautiful show. But crucially, it behaved exactly as we expected one of our own comets to behave. It began its activity when it got close enough to the sun. Its outgassing followed the predictable patterns, and its composition seemed, for the most part, quite normal. Borisov was comforting. It was a visitor who politely followed the local customs. It was, in the most respectful scientific sense, wonderfully boring because it confirmed that the rules of comet formation were similar in other star systems. 3I Atlas follows neither of these scripts. It is not silent and dry like Oumuamua, nor is it politely predictable like Borisov. It is an anomaly. It is a comet that has brought its own rules from its own home star, and those rules are profoundly different from ours. The central mystery, the question that is now being whispered in the halls of astronomy departments around the world, is simple. How? What is powering this impossible river of water? The sun's heat, at this distance, is simply not enough. Something else, some other mechanism, must be at work. It is as if we have found a campfire burning brightly in the middle of a frozen lake, and we have no idea who lit it or how it stays alight. Faced with this impossible observation, a river of water flowing where only frozen ice should exist, the scientific community has turned its collective mind to a single, challenging question. What is the engine? If the gentle, distant warmth of the sun isn't enough to power this activity, then some other process, either hidden within the comet itself or originating from its strange interstellar past, must be at play. Let us now drift into the quiet realm of scientific speculation, exploring the possibilities, each one more fascinating than the last, for what might be causing this visitor to breathe. The first and most straightforward idea is that 3I Atlas is not made of the same kind of ice as our own comets. Water ice, the kind we are familiar with, is a relatively stubborn substance. It needs a significant amount of energy to sublimate, to turn directly from a solid into a gas. This is why our solar system's comets stay dormant until they get much closer to the Sunday. But what if this visitor is carrying a different, more volatile kind of ice? Imagine ice is made of carbon dioxide, dry ice, or carbon monoxide. These substances are far more sensitive to heat. They can turn to gas at much lower temperatures in the deep freeze conditions of the outer solar system. If 3I Atlas contained large buried pockets of these super volatile ices, they could be the engine driving the activity. As the comet slowly warms on its journey inward, even the faint sunlight at 3.5 astronomical units might be enough to reach a critical threshold, causing these pockets to erupt. In this scenario, the water we are seeing would not be the primary fuel, but a secondary passenger. The erupting jets of carbon dioxide or carbon monoxide gas would violently tear away and carry with them chunks and grains of ordinary water ice. These icy grains, now thrown clear of the comet's nucleus and exposed directly to the vacuum of space, would have a much larger surface area and could sublimate much more quickly, even in the faint sunlight. So, the water isn't boiling off the surface of the comet. It's being blasted off by a different, more volatile engine hidden beneath the surface. This model is appealing because it would explain not just the water, but other anomalies in 3I Atlas's composition that we will explore later. Indeed, observations have suggested that this comet has an extraordinarily high ratio of carbon dioxide to water, a chemical signature that is backward compared to our own comets, and a strong clue that its internal chemistry is very different. It is as if our comets are built like snowballs, while this one is built more like a block of dry ice with flecks of snow embedded within it. Another possibility lies not in the comet's composition, but in its history. Is the comet's interior still warm? This may sound absurd, as we imagine space to be eternally cold, but the formation of a comet is a violent process. As the original ice and rock came together in the protoplanetary disk of its home star system, the countless collisions would have generated heat. Furthermore, if the comet incorporated radioactive elements from the gas cloud it was born from, the slow, steady decay of those elements could have provided a tiny but persistent internal heat source over billions of years. Perhaps 3I Atlas is like a cosmic hot water bottle, insulated by a thick outer crust, with a core that has remained just warm enough to keep some of its deep, internal water ice near its sublimation point. As it travels through our solar system, tiny fractures in its crust, perhaps caused by the gentle tidal pull of our sun, could be opening up, allowing this deep, pressurized water vapor to vent into space. In this model, the comet isn't being heated from the outside in, but is releasing its own ancient, primordial heat from the inside out. It would be a ghost of its own fiery formation, a memory of warmth preserved for billions of years in the deep freeze of interstellar space. A third and equally captivating idea involves the very shape and spin of the object. We do not yet have a clear picture of 3I Atlas's nucleus. It could be a simple, potato-shaped rock, but it could also have a much more complex topography, with deep canyons, towering cliffs, and shadowy valleys. It could also have a peculiar rotation if the comet is tumbling in a chaotic way, or if it is shaped in such a way that sunlight can be focused onto specific areas. It could create localized hot spots on its surface. Imagine a deep, bowl-shaped crater. As the comet rotates, sunlight might be able to shine directly down into the crater for a prolonged period, concentrating its energy at the bottom, like a giant magnifying glass. Even the faint sunlight of the outer solar system, if focused and trapped in this way, might be enough to heat a patch of ice to its sublimation point. These localized eruptions would be a function of the comet's own strange geography, its activity not uniform, but tied to the unique and perhaps bizarre landscape of its surface. Each of these theories paints a different picture of our interstellar guest. In one, it is a chemically alien object, its activity driven by exotic ices. In another, it is an ancient time capsule, still breathing with the warmth of its own birth. In a third, it is a world of strange and dramatic landscapes, where geography itself becomes the engine of activity. And of course, there is always the most thrilling and most remote possibility. Could this activity be artificial? It is the question that lingers in the quiet corners of any such discussion. For water to be expelled with such force and consistency, it would require energy. And while natural sources are possible, as we have explored, a technological source, a propulsion system, or a life support exhaust is another, more extraordinary possibility. We must be clear. There is no direct evidence to support this. The data, as strange as it is, does not require us to invoke alien technology, but the sheer statistical unlikeliness of 3I Atlas's behavior, its refusal to follow the script of any comet we have ever known, forces us to keep every door open. To a true observer, every hypothesis, no matter how wild, must be considered until it is disproven. For now, we are left to watch, to gather more data, and to wonder. The impossible breath of this cosmic visitor continues, and with every kilogram of water it releases into the void, the mystery only deepens. The story of 3I Atlas's impossible breath is not just about what it is doing now, but about the profound journey that brought it to our doorstep. To understand this visitor is to look backward in time, to trace its trajectory across the star-filled ocean of the galaxy, and to contemplate the nature of its original home. Every object in space carries a story written in its path, a history revealed by its orbit. And the orbit of 3I Atlas tells us, without any ambiguity, that it is a true wanderer, a traveler unbound by the gravity of our sun, a messenger from an unknown and distant star. When astronomers first spotted this faint point of light and calculated its trajectory, they immediately knew it was special. Its path through our solar system is not a closed, elliptical loop like the orbits of our planets, asteroids, and familiar comets. Instead, its path is hyperbolic. This is the technical term for an open curve, a trajectory that comes in from one direction, swings around the sun, and then heads back out into the depths of space, never to return. An object on a hyperbolic orbit has an eccentricity greater than 1, a mathematical signature that proves it is moving too fast to be captured by the sun's gravity. It is not a member of our solar system's family. It is just passing through. Using observations of its path, astronomers have been able to trace its origin point on the sky. The work involves a kind of cosmic archaeology, using powerful telescopes and immense star catalogs, like the one compiled by the Gaia Space Telescope, which has mapped the positions and movements of billions of stars in our galaxy. By running the clock backward, by simulating 3I Atlas's long journey through the gravitational field of the Milky Way, they can begin to make educated guesses about where it came from. And the answer is as fascinating as the object itself. The current evidence suggests that 3I Atlas may have originated from the thick disk of our galaxy. The Milky Way is not a uniform structure. Most of the young, bright stars we see, including our sun, reside in the thin disk, a relatively flat, dense plain of stars and gas that makes up the familiar spiral arms. But surrounding this is a more diffuse, puffed-up halo of stars, known as the thick disk. The stars in the thick disk are different. They are older, having formed much earlier in the galaxy's history, and they have a different chemical composition. They are metal-poor, meaning they contain fewer of the heavy elements that are forged in stars and scattered by supernovae over time. If 3I Atlas was born in a planetary system around one of these ancient, thick disk stars, it would mean that our visitor is not just a traveler, but a time capsule. Our own solar system is about 4.6 billion years old. The stars of the thick disk can be 7, 8, even 10 billion years old. This would make 3I Atlas an object that could be significantly older than our own sun, older than the Earth, a relic from a time when the galaxy was a younger and chemically simpler place. Think for a moment about what this means. This object would have formed in a cloud of gas and dust that had been enriched by fewer generations of exploding stars. Its building blocks would have been different from ours. It would have had plenty of the simple volatile elements like hydrogen, carbon, and oxygen, but fewer of the heavier, rocky elements like silicon and iron. Could this ancient, different chemistry be the key to its strange behavior? Perhaps comets that form in these older, metal-poor environments have a much higher proportion of volatile ices relative to their rock content. Perhaps the specific ratios of different ices, like carbon dioxide to water, are fundamentally different, leading to the kind of early, powerful activity we are seeing. This visitor is not just showing us what another star system is like. It may be showing us what our galaxy was like in its distant, forgotten youth. It is a chemical fossil, carrying a preserved sample of the interstellar medium from a different epoch of cosmic history. To study its composition is not just an act of astronomy, but of galactic archaeology. We are reading the layers of time, not in rock strata, but in the ice and dust of a visitor that has journeyed across billions of years to reach us. Of course, tracing an object's path back through billions of years of galactic motion is an incredibly complex task. The galaxy is not a static place. Stars are constantly moving, their orbits perturbed by the gravitational pull of the spiral arms, the central bar, and other passing stars. The trail is muddied by time. We can never know for certain which specific star 3I Atlas once called home, but the general direction, The possibility of its ancient origin opens a profound window into our understanding of the cosmos. This also forces us to expand our idea of what is normal. When we study the comets of our own solar system, we are studying a single data point. They all formed from the same well-mixed cloud, under the influence of the same star, and within the same planetary architecture. We have developed our models, our expectations, and our definitions of a comet based entirely on this one local example. But 3I Atlas, with its impossible water, and Oumuamua before it, with its strange shape, are telling us in no uncertain terms that our local rules do not apply to the rest of the universe. The galaxy is vast, and it has been building planetary systems for over 13 billion years. There must be an unimaginable diversity of worlds out there, formed under a staggering variety of conditions. Some will be like ours. Others, perhaps most, will be profoundly different. These interstellar visitors are our first, tantalizing physical samples of that diversity. They are the universe's way of reminding us that our backyard is not the only garden. Each interstellar object we find is a new letter in a cosmic alphabet we are only just beginning to learn. With enough of them, we might one day be able to read the language of galactic chemistry. We could begin to map the galaxy, not just by the light of its stars, but by the composition of its wanderers. This region produces carbon-rich comets. That region produces water-rich ones. And in that way, we could piece together a far more complete history of how our galaxy has evolved, how it has cooked its elements, and how it has distributed them through space and time. 3I Atlas, with its ancient origins and strange behavior, is one of the most exciting first letters in that new alphabet we have ever received. The story of 3I Atlas's impossible breath is made even more profound when we place it in its full chemical context. The river of water vapor, flowing at a staggering 40 kilograms per second, is only the most obvious signal from this enigmatic visitor. When astronomers train their powerful spectrographs on the faint light of the comet's coma, the thin, glowing atmosphere surrounding its nucleus, they are engaging in a form of cosmic forensics. They are breaking down the light into its constituent colors, searching for the unique spectral fingerprints left by different atoms and molecules. And the chemical signature of 3I Atlas is telling a story that is not just strange, but deeply and fundamentally alien to our own solar system experience. Let's begin with the carbon. Observations have revealed that 3I Atlas is extraordinarily rich in carbon-based molecules, particularly carbon dioxide. As we've noted, in the comets of our own solar system, water ice is usually the dominant component, the main engine of activity. Carbon dioxide is present, but typically as a secondary, less abundant ingredient. 3I Atlas appears to flip this script completely. Some early measurements suggest that up to 95% of its volatile emissions, the gases boiling off its surface, are composed of carbon dioxide, with water making up a much smaller fraction. This is a chemical signature that is profoundly different from anything we see at home. Why would a comet be so overwhelmingly dominated by carbon dioxide? The answer likely lies in the conditions of its birth. In a protoplanetary disk, the cloud of gas and dust that surrounds a young star, different ices condense at different distances from the star, a boundary known as the snow line. The water ice snow line is the distance beyond which temperatures are cold enough for water to freeze. Closer in, it remains a vapor. The carbon dioxide snow line is much farther out, in a colder region of the disk. A comet that is so rich in carbon dioxide likely formed in an extremely cold part of its home star system, perhaps far beyond the equivalent of our own Kuiper belt, in a region where CO2 was the primary ice available for collection. This would make 3I Atlas a true child of the deep freeze, a relic from a profoundly cold and distant nursery. Then there is the strange and compelling story of its metals. As 3I Atlas warmed, Astronomers at the Very Large Telescope in Chile detected the unmistakable spectral signature of nickel, glowing bright and green in the coma. This in itself is not unusual. Metals can be released from comets as they heat up. But what was profoundly shocking was the near-complete absence of iron. Nickel and iron, in our solar system, are like cosmic twins. They form together in similar processes within stars, and they condense into mineral grains together in protoplanetary disks. You almost never find one without the other, and certainly not in such a skewed ratio. Yet, here was a visitor pouring grams of nickel into space every second, with iron nowhere to be found. What could possibly explain this? One idea is a process called chemical fractionation. In the unique chemical environment of its home nebula, perhaps nickel was preferentially incorporated into highly volatile compounds, molecules that turn to gas at very low temperatures. Iron, meanwhile, may have been locked away in more refractory, heat-resistant minerals. As 3I Atlas warms, the nickel-bearing compounds are boiling off, releasing atomic nickel into the coma, while the iron-bearing rocks remain solid and dormant on the surface. This would require a set of chemical conditions during its formation that are very different from our own. Perhaps the gas in its home nebula was unusually rich in carbon monoxide, which can form volatile compounds with nickel. This again points to an origin in a different kind of stellar environment. And let us not forget the cyanide. The green glow of 3I Atlas's coma is also produced by the diatomic molecule of carbon and nitrogen, CN, or cyanide. This is a common cometary molecule, but its appearance in 3I Atlas was also telling. It seemed to switch on later in the warming sequence, after the water was already flowing profusely. This suggests that the cyanide might be trapped in a different way, perhaps locked within more complex organic molecules that require more energy to break down, or perhaps buried in layers beneath the most volatile ices on the surface. So, when we put these chemical clues together, the impossible water, the dominant carbon dioxide, the nickel without iron, the delayed cyanide, a picture begins to emerge. This is not just a comet. This is a chemical artifact. It is a piece of a different world, built from a different recipe. If its origin is indeed the ancient thick disk of the galaxy, as its trajectory suggests, then it could be carrying a chemical signature of a time when the universe itself was chemically younger, before generations of supernovae had fully seeded the cosmos with the heavy elements we now see as common. It is impossible to discuss this strange and potent chemical cocktail without a quiet nod to the panspermia hypothesis, the idea that comets could act as cosmic delivery systems, seeding barren planets with the building blocks of life. Let us be very clear. This is speculation. There is no evidence that 3I Atlas is carrying life, but what it is carrying, water, complex carbon chemistry, and nitrogen compounds like cyanide, are the exact prebiotic ingredients that scientists believe were necessary for life to begin on early Earth. This object is a demonstration, a proof of concept, that these vital ingredients can be transported across interstellar space, shielded within the icy heart of a comet. It shows us that the chemistry required for life is not necessarily unique to our own solar system. The universe may be constantly shipping these prebiotic starter kits from one star system to another, each one a tiny, frozen ark, carrying not life itself, but the potential for it. Every time a visitor like 3I Atlas passes through, it is a reminder that the great cosmic ocean is not sterile, but filled with the chemical seeds of possibility, and to observe its strange, life-giving chemistry in action, even from a distance of millions of kilometers, is to witness a quiet and profound message of hope. As we delve deeper into the mystery of 3I Atlas and its impossible breadth, we must acknowledge the limitations of our perspective. We are observing this traveler from an immense distance, through the faint and subtle language of light. While our telescopes are powerful, they can only tell us so much. They show us the what, the water, the nickel, the strange chemistry. but they struggle to fully reveal the why. To truly understand the engine driving this comet's activity, we would need to get closer, much closer. This is where the quiet dream of interstellar interception begins, a field of mission design that is as ambitious as it is scientifically thrilling. Let us imagine, for a moment, that we could send a robotic emissary to meet this visitor. A spacecraft, launched from Earth, designed not just to fly past, but to match its incredible velocity, to rendezvous with it in the cold darkness of space, and to become its temporary companion. The technological challenges of such a mission are staggering. Interstellar objects move through our solar system at speeds of tens of kilometers per second, relative to the Sunday. To catch one, a spacecraft would need to be either incredibly fast or incredibly patient, launched on a trajectory that is calculated with breathtaking precision. Proposals for such intercept missions already exist. One concept, known as Project Lyra, developed by the Initiative for Interstellar Studies, outlines how a spacecraft could use a combination of powerful rockets and a gravitational assist from the Sun or a planet like Jupiter to achieve the necessary speed. It would be a mission launched at a moment's notice, a rapid response to the detection of a new interstellar visitor. The spacecraft would be a marvel of lightweight design and powerful propulsion, a cosmic sprinter designed for the chase of a lifetime. If we were to succeed in sending such a probe to 3I Atlas, what would it see as it approached? From a distance, the comet would still appear as a bright, star-like point, surrounded by its faint, glowing coma. But as the probe drew closer, this point of light would resolve into a solid object, the nucleus. For the first time, we would see its true shape and form. Is it a single elongated body like Oumuamua was thought to be? Or is it a strange, bi-lobed object, like some comets in our own solar system, two icy spheres gently fused together? Or is it something else entirely? A chaotic agglomeration of smaller bodies, a rubble pile held together loosely by its own weak gravity. Our probe would be able to map its surface in exquisite detail, revealing the source of its impossible activity. We would see the vents, the fissures from which the 40 kilograms of water per second are gushing into space. Are they clustered in one geologically active region, a kind of cometary geyser field? Or are they scattered across the surface, a testament to a porous and universally active interior? We would be able to measure the temperature of these vents, to analyze the gas composition right at the source, and to see if the eruptions are continuous or if they pulse and sputter with a hidden rhythm. A landing, of course, would be the ultimate prize. To gently touch down on the surface of an object from another star system would be one of the most profound achievements in the history of exploration. The surface itself would be an alien landscape, not the familiar gray dust of our moon or the red sands of Mars, but a terrain of ancient, pristine ice, mixed with dark, carbon-rich dust, a surface that has been bombarded by cosmic rays for perhaps billions of years. It would be a world of extreme contrasts, the deep, absolute black of the shadows and the brilliant, reflected glare of a distant Sunday. Our lander could drill beneath this irradiated crust, into the deeper, more protected layers of ice. Here, it would find the most ancient and unaltered material, a chemical time capsule from the comet's birth. By analyzing these samples on the spot, with sophisticated onboard laboratories, we could finally answer the great questions that 3I Atlas poses. Is the nickel-to-iron ratio truly anomalous, or is it a surface effect? Are the volatile ices of carbon dioxide and monoxide the true drivers of its activity? And are their complex organic molecules the very building blocks of life trapped and preserved within its frozen heart? To hold a piece of this object, even robotically, would be to hold a piece of another world in its most elemental form. The science we could do would be transformative. We could determine its precise isotopic ratios, the different weights of its atoms, which act as a definitive fingerprint of its parent star. Every star system has a unique isotopic signature, and by matching the comet's signature to the vast library of stars, we might one day be able to pinpoint, with a high degree of confidence, the very star that 3I Atlas once called home. We would no longer be guessing about its origins in the thick disk. We would know. Even without a landing, an orbiting probe could teach us volumes. By measuring the comet's gravitational field with exquisite precision, we could determine its mass and density, revealing whether it is a solid, coherent body or a light, porous fluffball of ice. We could use radar to peer beneath its surface, mapping its internal structure and searching for cavities or hidden reservoirs of gas and liquid. We could fly through the jets of water vapor, sampling them directly, and build a complete and unambiguous inventory of every molecule it is exhaling into space. Such a mission is, for now, a beautiful and distant dream. 3I Atlas itself is already moving too fast and is too far away for us to catch it with any technology we currently have ready. We missed this chance, but it has served as a profound and inspiring wake-up call. It has shown us that these visitors are not just once-in-a-lifetime oddities. They are a regular, if rare, feature of our solar system's traffic. And it has ignited a serious and passionate conversation within the scientific community about the need to be ready for the next one. The dream of interstellar interception is a quiet testament to humanity's deepest and most noble instinct, the drive to explore, to touch the unknown, and to understand our place in the cosmos. 3I Atlas, in its impossible, watery breath, is not just a scientific puzzle. It is an invitation, it is a challenge, and it is a promise of the extraordinary discoveries that still await us, out there in the quiet and beautiful darkness between the stars. As we ponder the immense and almost insurmountable challenge of physically traveling to our interstellar guest, it is comforting to remember that the universe has already provided us with a messenger service of unparalleled elegance and efficiency: light itself. Every photon that journeys from 3I Atlas and arrives at our telescopes is a tiny, information-rich package, a letter from the void that has traveled for months or even years to tell us its story. While a physical mission remains a dream for the future, the art and science of observing this visitor from afar is happening right now, and it is a masterpiece of human ingenuity. To observe an object, like 3I Atlas, is not as simple as pointing a telescope and taking a picture. The comet is incredibly faint, a tiny speck of reflected sunlight against the vast, dark canvas of space. To capture its image requires hours of exposure time, where a telescope stares, unblinking, at a single point in the sky, slowly gathering every precious photon. But there's a problem. The comet is moving, and so is the Earth. To get a clear picture, the telescope must track the object's precise, predicted motion across the starfield with a degree of accuracy that is almost beyond belief. It is like trying to photograph a specific firefly in a distant field from a moving car at night. Once the light is collected, the real work of observation begins. The primary tool of the astronomer in a case like this is spectroscopy. By passing the faint light of the comet through an instrument called a spectrograph, astronomers can spread it out into its constituent colors, a rainbow known as a spectrum. But this is not just a pretty band of light. Woven into this spectrum are fine, dark lines where specific colors are missing, or bright, sharp lines where specific colors are being emitted. These are the spectral fingerprints we discussed earlier, unique to each atom and molecule. To an experienced astronomer, a spectrum is not a picture. It is a text, a chemical composition, written in the language of light. It was through this painstaking process that the impossible breath of 3I Atlas was discovered. Astronomers saw the telltale signature of hydroxyl, OH, in the ultraviolet part of the spectrum, the irrefutable evidence of water. They saw the glowing green emission lines of cyanide, CN, and diatomic carbon, C2, common in comets. And, of course, they saw that strange, glaring signature of nickel, glowing brightly, while its companion, iron, remained mysteriously silent. Each of these discoveries was a triumph of observation, the result of pulling a faint and subtle signal out of the cosmic noise. Another powerful tool is photometry. This is the science of measuring the brightness of an object over time. By observing how a comet's brightness changes, astronomers can learn about its rotation. As 3I Atlas tumbles through space, it presents different sides of its nucleus to us. A wider, more reflective side will appear brighter, while a narrower, darker side will appear fainter. The steady, wave-like pattern of this brightening and dimming is what revealed the comet's 16-hour rotation period. But photometry can also detect sudden, unexpected events. An outburst, where a pocket of volatile ice suddenly erupts, would cause a sharp and dramatic increase in brightness, a flash in the data that tells a story of an unstable and active surface. It is through careful and continuous photometric monitoring that the rhythmic, 2-hour pulses of 3I Atlas's brightness, now being investigated, might be confirmed or refined. Then there is the quiet and subtle art of polarimetry. Light from the sun is unpolarized, meaning its waves vibrate in all directions. But when this sunlight reflects off a surface, like the dust grains in a comet's coma, it becomes polarized. It begins to vibrate more in one direction than another. By measuring the angle and degree of this polarization, astronomers can learn about the properties of the dust itself. Are the grains large or small? Are they fluffy and porous, or are they compact and solid? Are they made of dark, carbon-rich material, or bright, silicate-rich rock? The polarized light is a clue, a subtle whisper that tells us about the texture and composition of the very stuff that 3I Atlas is made of. Each of these techniques, imaging, spectroscopy, photometry, polarimetry, provides a different piece of the puzzle. When combined, they allow scientists to build a remarkably detailed, multi-layered picture of an object that we will never physically touch. We are observing our visitor not just with our eyes, but with a full suite of senses, each one attuned to a different property of light. And this work is not being done by one person at one telescope. It is a global, collaborative effort. When an object this important appears, a call goes out to the astronomical community. Observatories around the world, from the mountaintops of Chile and Hawaii to the space-based telescopes orbiting above our atmosphere, coordinate their observations. One telescope might be an expert in ultraviolet spectroscopy. Another in infrared imaging. One might be able to observe for a few hours at the beginning of the night, while another, on the other side of the world, can pick up the observation as the Earth turns. It is a slow, patient, and global collaboration, a testament to the scientific spirit of shared knowledge. In a world so often divided, the quiet and coordinated effort to understand a visitor from another star is a beautiful thing. It is humanity, at its best, coming together not for profit or for power, but for the simple and profound love of knowing. And every one of us, even those without a telescope, can participate in this journey by following the discoveries, by reading the papers, and by engaging in the quiet contemplation of what they mean. In the end, to observe a thing is to connect with it. And through the patient and persistent observation of 3I Atlas, we are forging a connection not just with a single, strange comet, but with the vast and wondrous universe that sent it our way. As we stand in awe of the elegant science and global cooperation being marshaled to observe 3I Atlas, we must also acknowledge a more frustrating and human element of this story: the gatekeeping of information. In an age of unprecedented connectivity, where a discovery made in a Chilean observatory can be known in an instant by a scientist in Japan, there are still walls. Some of these walls are technical, but many are political and cultural. The story of what we don't yet know about 3I Atlas is as revealing as the story of what we do. As we've discussed, The most powerful images of this interstellar visitor have almost certainly already been taken. The high-rise camera on NASA's Mars Reconnaissance Orbiter and the instruments on the Psyche probe have likely had clear, high-resolution views of the object, opportunities that ground-based telescopes peering through Earth's shimmering atmosphere can only dream of. Yet, these images remain under lock and key. The official excuse for the high-rise images has been the U.S. government shutdown, a convenient and, frankly, flimsy justification that has now stretched on, delaying the release of what could be the most important astronomical data of our time. And the Psyche images, taken before the shutdown, have simply never been mentioned, a silence that is louder and more damning than any excuse. This withholding of data, whether intentional or bureaucratic, creates a vacuum. And in that vacuum, speculation, frustration, and mistrust begin to grow. The scientific process, at its best, is a transparent one, where data is shared openly and hypotheses are tested and debated by a global community. When data is held back, it undermines that process. It creates an environment of insiders and outsiders, of official narratives and whispered rumors. It runs counter to the very spirit of open and collaborative discovery that science is supposed to champion. We, the public, the taxpayers who fund these missions, the curious minds who look to these agencies for knowledge and inspiration, are left to wait. We are told to be patient, to trust the process. But trust is a two-way street, and it is eroded by a lack of transparency. The silence from the agencies in charge is not a sign of careful, methodical work. It has begun to feel like an act of control, an attempt to manage the narrative, to ensure that any world-changing discovery is presented to the public on their terms and on their schedule. This is not a new phenomenon. The history of science is filled with stories of discoveries that were suppressed, delayed, or ignored because they challenged the established paradigm. From Galileo being placed under house arrest for his heliocentric model, to the initial dismissal of Cecilia Payne's groundbreaking work on the composition of stars, the scientific establishment has often shown a deep and profound resistance to ideas that threaten to overturn the comfortable consensus. The possibility that 3I Atlas could be an artifact of extraterrestrial intelligence is the ultimate paradigm-shattering idea. And it is not surprising, though it is disappointing, that the institutional response has been one of extreme caution and control. But we live in a different age. Information is no longer held exclusively by a small group of high priests in their institutional temples. The rise of the Internet, the open sharing of data from some projects, and the global network of citizen scientists and independent researchers have created a more democratized landscape for discovery. The paper from Medvedev and Pavlov, published openly on the Astronomer's Telegram for any to see, is a perfect example of this new reality. They did not wait for the long, slow, and often political process of traditional journal publication. They shared their findings immediately, trusting in the global community to scrutinize, test, and build upon their work. This is the future of science, more open, more immediate, and more collaborative. This tension between the old, closed model of gatekeeping and the new, open model of global collaboration is at the very heart of the 3I Atlas story, and it raises a profound question. Who owns a discovery? If an object is found that has the potential to reshape humanity's understanding of itself, does that information belong to the agency that took the picture, or does it belong to humanity? I believe the answer is clear. A discovery of this magnitude is the shared heritage of all people. It is not something to be managed, to be spun, or to be released at a politically convenient moment. It is something to be shared, to be contemplated, and to be marveled at together. So, what can we do as observers on the outside of these locked gates? We can keep asking the question, loudly, respectfully, and relentlessly. Where are the images? Why are they not being released? We can support the scientists and the journalists who are pushing for transparency, and we can continue to do our own work, to analyze the data that is public, to make our own observations, and to participate in the global conversation. We must demonstrate, by our own actions, the value of open and independent inquiry. It is a strange and beautiful irony that a visitor from another star system, a messenger from the deep and silent dark, has arrived in our solar system only to shine a bright, unforgiving light on our own human systems of knowledge and power. The mystery of 3I Atlas is not just a scientific one, it is now a social and political one as well. And how we, as a global community, navigate this moment of secrecy and anticipation will say a great deal about our own maturity as a species. Will we wait passively to be told what to believe, or will we continue to observe, to question, and to demand the truth? As we navigate the frustrating silence from official sources and piece together the clues from the data we do have, it is worth pausing to place the strange behavior of 3I Atlas into an even grander cosmic context. This object is not just unusual. It is behaving in a way that feels almost alive, its impossible breath, a rhythmic pulse in the cold vacuum of space. And this leads us to one of the most profound and humbling questions in all of science. What does it mean to be alive? And could the universe have found other ways to be active, to be dynamic, that do not fit our narrow biological definition of life? On Earth, our definition of life is a beautiful and specific one. It is based on carbon chemistry, on cells with membranes, on the elegant spiral of DNA, and on the steady, energetic dance of metabolism. We recognize life by its ability to grow, to reproduce, to respond to its environment, and to evolve. But this is the only example we have ever known. It is a single, precious data point in a universe of almost unimaginable size and variety. To assume that all life, or all complex active systems, must follow this same blueprint is a profound, if understandable, failure of the imagination. Let us, for a moment, set aside the idea of a technological, intelligently designed probe and consider a third, more poetic possibility. What if there are natural, non-biological processes in the universe that can mimic the behaviors we associate with life? What if a comet, formed under a set of truly exotic conditions, could develop a kind of complex, self-sustaining geology that makes it appear to be breathing? Imagine a comet with a porous, sponge-like interior, riddled with interconnected caverns and fissures. Imagine that these caverns are filled with a cocktail of different ices, some of which turn to gas at extremely low temperatures. As the comet slowly warms on its journey through our solar system, a chain reaction could begin deep within its core. A pocket of super-volatile carbon monoxide ice might sublimate first, creating a pocket of high-pressure gas. This pressure could force its way through the fissures, causing a geyser that expels not just gas, but also the more stubborn water ice, leading to the activity we see. The system could even be self-regulating. The eruption might cool the interior, temporarily shutting down the process, until heat slowly builds up again, leading to a rhythmic, pulsing breath. In this scenario, the comet would have a kind of metabolism, but a geological one, not a biological one. Its activity would be driven not by cells and enzymes, but by the physics of phase transitions and the unique architecture of its interior. It would be a world unto itself, a small, icy planetoid with its own internal weather system, its own cycle of pressure and release. It would not be alive in the way a microbe is alive, but it would not be a dead, inert rock either. It would exist in a beautiful and fascinating gray area, a complex and dynamic system that challenges our simple categories of living and non-living. This idea stretches our perspective. We are accustomed to thinking of geology as a slow, patient, and largely passive process, But the universe is full of examples where geology is anything but. Consider the cryovolcanoes on Saturn's moon, Enceladus. We see great plumes of water ice erupting from its south pole, driven by an internal heat source that keeps a vast, liquid ocean warm beneath its icy shell. Enceladus is not alive, but it is geologically active on a spectacular scale. Could 3I Atlas be a tiny interstellar cousin of Enceladus, a fragment of a larger, once active world, carrying within it a preserved engine of geological activity? Or perhaps, the explanation lies in a form of chemistry that is entirely new to us. Our understanding of chemistry is based on the conditions here on Earth and what we have observed in our solar system. But what if, in a star system with a different chemical composition, or under the influence of a different kind of stellar radiation, molecules can form that have properties we have never encountered? Imagine a form of ice that can store and release energy in a cyclical way, a rechargeable chemical matrix. Imagine compounds that can undergo slow, sustained, exothermic reactions, reactions that produce their own heat when triggered by a small, initial input of solar energy. We would look at such an object and see it breathing, living, powered by an impossible internal furnace. We might be tempted to call it artificial, because it would be behaving in a way that no natural object we know could. But the truth would be that our definition of natural was simply too small. We would not be looking at technology. We would be looking at a new chapter in the great book of cosmic chemistry. This is what makes the study of interstellar visitors so profoundly important. They are our only hope of expanding our sample size beyond one. Each one is a messenger, not just of its origin, but of the possibilities that the universe allows. To find a comet that breathes through an exotic geological process would, in its own way, be just as revolutionary as finding an alien probe. It would tell us that the universe is not only more creative than we have imagined, but that the very line between a rock and a world is blurrier and more beautiful than we ever thought. And in that thought, there is a deep and profound calm. It suggests that the universe is filled not just with dead matter and living biology, but with a whole spectrum of complexity in between. There may be worlds that hum with a quiet geological pulse. There may be crystals that grow in complex, information-storing patterns. There may be clouds of gas that exhibit a kind of collective, emergent behavior. We do not need to find little green men to discover that the cosmos is a far more active and, in a sense, more alive place than we have ever dared to dream. 3I Atlas, in its impossible, watery breath, is our first, tantalizing hint of this grander, stranger reality. As we continue to observe this interstellar messenger from our distant terrestrial shore, it's natural to wonder about its ultimate fate and the final act of its journey through our solar system. The path of 3I Atlas is a hyperbolic one, a graceful arc that will carry it around the sun and then fling it back out into the endless ocean of interstellar space. Its visit is a fleeting one, but the most dramatic part of its journey is still ahead, its perihelion, the point of its closest approach to the Sunday. It is in this moment of most intense heat and gravitational stress that the true nature of our visitor may finally be revealed. On or around October 29th and 30th, 3I Atlas will reach this critical point in its orbit. It will be deep inside the orbit of Mercury, subjected to a torrent of solar radiation and gravitational forces that are almost unimaginable. For any object, let alone one made of ancient ice and rock, this is the ultimate trial by fire. And for us, the observers, this is a moment of profound anticipation. The central question that every astronomer is waiting to have answered is this: will it survive? There are, broadly, two possibilities, and each one carries its own profound implications. The first possibility is the one that many mainstream astronomers expect, and perhaps are quietly hoping for. It is the possibility of natural disintegration. A comet is not a solid, monolithic block of stone. It is a loose agglomeration of ice, dust, and rock, a dirty snowball held together by its own fragile gravity and the cementing effect of its frozen ices. As it nears the sun, this structure is put under immense stress. The intense solar heat will cause the ices on its surface and just beneath it to sublimate with ferocious violence. We are already seeing this begin with the impossible outgassing of 40 kilograms of water per second. At perihelion, that rate will increase by orders of magnitude. The jets of gas erupting from its surface will be immensely powerful, and if the comet's nucleus is not structurally sound, these jets could act like explosive charges, tearing the object apart from the inside out. At the same time, the sun's immense gravitational pull will be exerting powerful tidal forces on the comet, stretching and squeezing it, further testing its internal cohesion. If 3I Atlas is a natural, loosely held together comet, there is a very high probability that it will not survive this passage. It could break apart into a string of pearls, a chain of smaller fragments, much like comet shoemaker Levy 9 did before it plunged into Jupiter. Each of these fragments would then continue along a similar orbit, each one a smaller, less spectacular version of the original. Or, in a more dramatic scenario, the entire object could completely disintegrate, vaporizing into a vast, transient cloud of gas and dust that will briefly light up the inner solar system before being blown away by the solar wind. If this happens, it would be a spectacular and beautiful end to the story, and for many in the scientific community, it would be a comforting one. It would confirm the natural comet hypothesis in the most definitive way possible. It would be a messy, chaotic, and gloriously natural event. The mystery would be solved. The breathing comet was just a fragile snowball that couldn't handle the heat. But there is a second possibility. What if it survives? What if 3I Atlas passes through the furnace of its closest approach to the sun and emerges on the other side, intact and still on its clockwork schedule? What if it endures the immense heat, the tidal stress, and the violent outgassing, and continues its journey back out into the void as a single, coherent object? That, my friends, would be an anomaly of a different order entirely. For an object to survive such a close pass, it would have to possess a tensile strength, an internal structural integrity far greater than that of a typical comet. A rubble pile, held together by ice and weak gravity, would be torn to shreds. But an object that is solid, that is made of a much stronger material, or an object that is intelligently designed with a reinforced structure, might endure. If 3I Atlas survives its perihelion, the natural comet theory takes a massive, perhaps fatal, blow. It would be a powerful piece of evidence suggesting that this is no ordinary dirty snowball. Avi Loeb has presented exactly these two hypotheses. 1. A natural event. The comet breaks apart. 2. An artificial one. The object remains intact and perhaps even releases a fleet of probes at its point of closest approach, using the sun's gravity and the object's own momentum as a natural deployment mechanism. This second idea is pure speculation, of course, but it is a logical extension of the artificial hypothesis. A probe arriving in a new system might use the moment of greatest stress and gravitational advantage to deploy smaller, localized observation units. And I would add a third possibility, one that aligns with the quiet, stealthy nature of our first interstellar visitor, Oumuamua. The third hypothesis is that it does not break apart. It does not release a fleet, but it does exactly what Oumuamua did. It uses its close pass of the sun to perform a powerful gravitational slingshot and a powered maneuver to accelerate itself with incredible efficiency on its way to its next destination. In this scenario, it would be a demonstration of a perfectly executed, long-planned trajectory, a masterpiece of celestial navigation. Whichever of these outcomes comes to pass, the moment of perihelion will be the great reveal. We will be watching with every instrument we have, from our solar telescopes that can track it into the glare, to the great space observatories that will be waiting to pick it up as it emerges from the other side. This is not just a scientific observation. It is a moment of truth, a cosmic test of our most cherished and most challenging ideas about the universe and our place in it. The fire of the sun will be the ultimate judge, and its verdict is coming soon. As we stand here at the midpoint of our deep exploration, with the perihelion of 3I Atlas looming like a final exam on the cosmic horizon, it is a perfect time to take a quiet breath and look at the bigger picture. We have ventured into the heart of a profound scientific mystery, a story filled with impossible data, suspicious silences, and the thrilling possibility that we are not alone. It is a story that demands our attention and our critical thought. And if this journey into the unknown resonates with you, if the quiet act of observation and the fearless asking of big questions is something you value, then I invite you to become a more permanent member of this crew. A simple click on the like button helps this video reach other curious minds. And by subscribing, you ensure that you won't miss a single update as this incredible real-time story unfolds. This channel is, and will always be, powered by its community, and I am deeply grateful for every one of you who chooses to be a part of it. Now, let's dive back into the swirling currents of this mystery and turn our attention to an idea we touched on at the very beginning: the fleet. When I first showed you the simulation of our inner solar system, with 3I Atlas making its passage, you saw that it was not alone. It is accompanied by at least 17 other known comets, all present in the same general region of space during the same period. On its face, this could be a coincidence. Comets are a common feature of our solar system, their orbits sometimes bringing several into view at once. The mainstream narrative would tell you to dismiss this as nothing more than a statistical inevitability. Look at enough sky for long enough, they would say, and you're bound to see a few comets at the same time. But as observers, our job is not to accept the simple explanation without questioning it. It is to look at the pattern and ask, is this truly random? The concentration of so many comets in this specific time frame, all coinciding with the arrival of our third ever confirmed interstellar visitor, is, at the very least, statistically interesting. It feels less like a random sprinkling and more like a gathering. The simulation I showed you revealed an even stranger pattern. Many of these comets appear to be concentrated around our Sun and the inner planets during the passage of 3I Atlas, and then, as our interstellar guest begins to depart, the fleet seems to disperse, its members heading off in their own directions. It's a subtle and tantalizing piece of visual data, not a scientific proof, but a pattern that begs for a deeper look. What could this fleet be? If not a coincidence, let's explore the possibilities, from the natural to the truly extraordinary. One natural explanation we've considered is the Oort cloud disturbance theory, that 3I Atlas, in its long journey inward, passed through our solar system's distant Oort cloud and gravitationally scattered a cluster of comets, sending them tumbling towards the sun ahead of its own arrival. This is a plausible idea, but as we discussed, it has its problems. It would require 3I Atlas to be unusually massive, and it doesn't quite explain the seemingly coordinated timing and dispersal of the group. Another, more exotic natural explanation could involve a shared origin. What if this cluster of comets, and perhaps even 3I Atlas itself, are all part of a single, ancient, cometary stream, the debris from a much larger object that broke apart long ago in interstellar space? In this scenario, they wouldn't be a fleet in the intentional sense, but more like a scattered family of fragments, all traveling on roughly similar trajectories through the galaxy, and all just happening to arrive in our solar system at the same time. This would explain their shared presence, but it would be an incredible and almost unbelievably rare event. But now, let's step into the more speculative, alien hypothesis territory. If 3I Atlas is an artificial probe, what could this fleet be? The most thrilling possibility is that they are not comets at all. What if they are also probes? What if the official comet designations are just a convenient label for a series of objects we do not fully understand? This is a grand and perhaps fanciful idea, but not one without a certain logic. An advanced civilization on a mission of galactic reconnaissance might not send a single monolithic vessel. They might send a mothership, 3I Atlas, accompanied by a fleet of smaller, specialized drones. Some might be for long-range communication, others for detailed planetary scanning. Still others might be passive listening posts. The 17 comets could be the outriders, the scouts, the support vessels for a much larger and more complex mission. Their cometary behavior, if they are indeed outgassing, could even be a form of camouflage, a way of blending in with the natural cosmic traffic to avoid attracting too much attention. Or, to take it a step further, let's return to Avi Loeb's second hypothesis for 3I Atlas's perihelion. What if the fleet doesn't arrive with the object, but is deployed by it? Imagine 3I Atlas as a carrier. It makes its close, high-stress pass of our sun, and at the moment of perihelion, it opens up and releases a swarm of smaller probes, which then use the sun's gravity and the carrier's momentum to efficiently disperse throughout our solar system. The fleet we see now could just be our own local comets, a distracting coincidence. But the real fleet could be yet to come, a technological birth about to happen in the heart of our solar system. These are immense, mind-stretching ideas, and we must hold them lightly. They are speculation, built on a foundation of data that is still incomplete. But the presence of this strange, celestial gathering demands that we ask these questions. To dismiss the fleet as a mere coincidence without a second thought is not an act of scientific rigor. It is an act of intellectual incuriosity. We are observers, and the pattern is there to be observed. In the coming months, as 3I Atlas and its companions continue their journeys, we will watch them all. We will track their paths. We will look for any signs of coordinated movement, any shared and unusual behavior. The story may be written not just in the breath of one object, but in the silent, synchronized dance of many. As we delve into the intricate dance of 3I Atlas and its accompanying fleet, it is easy to become lost in the grand spectacle of their trajectories. But we must not forget one of the most fundamental and quietly compelling anomalies of all, a clue written not in motion but in matter itself. The very substance of our interstellar visitor appears to be different, carrying a chemical signature that defies the common recipe of our own solar system. This is the strange and revealing story of the nickel without the iron. Let us return to that crucial observation from the Very Large Telescope in Chile. Using its powerful spectrograph to dissect the faint light from the comet's coma, astronomers found a strong, undeniable emission line from atomic nickel, glowing brightly in the green part of the spectrum. The data indicated that about 5 grams of nickel were sublimating off the object's surface every single second. But what was astonishing, what made this a headline in the astronomical community, was the near-total absence of iron. In our solar system, this simply doesn't happen. Iron and nickel are what chemists call siderophiles, or iron-loving elements. They are forged in the same explosive deaths of massive stars, and they have very similar chemical properties, meaning they tend to condense and lock into the same mineral structures in the cold dust of a protoplanetary disk. In every meteorite we have ever analyzed, in every asteroid we have ever studied, in every comet from our own Oort cloud or Kuiper belt, the ratio of iron to nickel is remarkably consistent. Iron is always the dominant partner. Finding an object that is rich in nickel but poor in iron is like finding a forest with leaves but no trees. It suggests a fundamental misunderstanding of the underlying processes, or, more excitingly, that the processes themselves were entirely different. So, how can we explain this? What story is this anomalous metal ratio trying to tell us about the origins of 3I Atlas? The most scientifically cautious explanation is, as we've touched upon, chemical fractionation. Perhaps in the unique environment where this comet was born, the chemistry of the protoplanetary disk was such that nickel and iron went their separate ways. Imagine a region of the disk that was exceptionally rich in carbon monoxide. Nickel has a peculiar ability to bind with carbon monoxide molecules to form a volatile compound called nickel carbonyl. This substance turns to gas at relatively low temperatures. Iron forms similar compounds, but they are generally less stable. It is theoretically possible that in its home system, nickel was captured into these volatile, carbonyl-rich ices, while iron remained locked away in heavier, silicate rock. As 3I Atlas now warms in our Sun, these nickel-bearing ices are sublimating, releasing the nickel atoms into the coma, while the iron stays put, entombed in the comet's rocky heart. This would be an elegant, natural explanation. It requires no alien engineers, only a specific and, perhaps, unusual set of chemical conditions. However, it also implies that the star system, where 3I Atlas was born, was chemically very different from our own, a place where carbon monoxide was so abundant it could fundamentally alter the way metals were distributed. This, in itself, is a profound discovery. It would be direct evidence of the vast chemical diversity of planetary systems throughout the galaxy. Another possibility involves the exotic physics of space weathering. For millions, perhaps billions, of years, 3I Atlas has been a lonely wanderer in the interstellar medium. During that immense journey, its surface has been relentlessly bombarded by high-energy cosmic rays and ultraviolet radiation from countless stars. This is not a gentle process. It is a slow, grinding form of cosmic erosion that can fundamentally alter the chemistry of a surface. Could this radiation processing have selectively enriched the surface layers with nickel, or perhaps depleted them of iron? It is a complex idea, and the exact mechanisms are not well understood, but it's another natural avenue that scientists are exploring. In this view, the nickel we see is not representative of the whole object, but is merely a thin, radiation-damaged skin. But then, we must entertain the more extraordinary hypothesis, the one that aligns with the object's other strange, clockwork behaviors. What if this unusual metal ratio is not natural at all, but artificial? In our own industrial processes here on Earth, the separation of iron and nickel is not just possible, it is fundamental. We refine iron to make steel for construction. We refine nickel for use in batteries, in stainless steel alloys, and in high-tech electronics. The process of metallurgy is the art of separating elements based on their useful properties. An advanced civilization that engages in any form of space-based industry, mining asteroids, building habitats, constructing starships, would, by necessity, become masters of this process. They would generate vast quantities of refined metals, and they would also generate waste products, slag, and tailings with highly anomalous elemental ratios. Could 3I Atlas be, in some form, a product of such an industrial process? It doesn't have to be a pristine, polished starship. It could be an industrial vessel. It could even be, as some have speculated, a piece of industrial waste, a slag heap from an ancient asteroid mining operation that was cast off and has been drifting through the galaxy ever since. Its anomalous nickel content would not be a mystery. It would be a made-by stamp, a clear and undeniable techno-signature. This is, of course, a wild and speculative leap, but it is one that fits the chemical data in a way that the natural explanations, with their requirements for very specific and unusual conditions, struggle to do. Every piece of evidence we have about this object, its impossible water, its harmonic maneuvers, its lack of a tail, and its strange chemistry all point in the same direction. This is not a normal comet. Each anomaly, on its own, might be explainable with a sufficiently creative natural model. But when you stack them all together, the argument for a simple, natural explanation becomes strained to the breaking point. The principle of Occam's razor suggests we should favor the simplest explanation that fits all the facts. And it is becoming increasingly plausible that the simplest explanation is not a magically complex comet, but a technologically simple by their standards machine. As we continue to build the case file on 3I Atlas, with each piece of evidence pointing toward something truly extraordinary, we must not lose sight of the grand, theatrical nature of this entire affair. It feels, at times, like we are not just observers of a scientific mystery, but audience members in a carefully staged cosmic drama. And in this drama, the timing of events, the curious alignments, and the almost too perfect coincidences have begun to feel less like random chance and more like a deliberately written script. Let's now turn our attention to the strange and sometimes surreal stagecraft that has accompanied the arrival of our interstellar guest. Let's talk about Mercury and Ceres. In early October 2025, just as the buzz around 3I Atlas and its impossible behavior was beginning to build, amateur and professional astronomers were treated to excellent viewing conditions for two other celestial bodies: Mercury, the innermost planet, and Ceres, the largest object in the asteroid belt. Mercury was in a favorable evening apparition, shining brightly in the twilight sky. Ceres was at opposition, meaning it was at its closest and brightest for the year. Online forums and social media channels lit up with discussion. Did you see Mercury last night? Ceres is incredible through a small telescope. And then, inevitably, the connections started being made. People began to ask, is this related? Is there some cosmic alignment between Mercury, Ceres, and the strange activity of 3I Atlas? Could their combined gravitational pull be triggering the outgassing? Is it all part of some grand resonant system that we don't yet understand? Let's be absolutely unequivocally clear on this point. Scientifically, the answer is no. The gravitational influence of a tiny planet like Mercury and a dwarf planet like Ceres on an object hundreds of millions of kilometers away is, for all intents and purposes, zero. It is a whisper in a hurricane. There is no known physical mechanism by which their positions could cause 3I Atlas to start breathing water. These are independent, unrelated celestial events that just happen to be occurring at the same time. But this is where we, as critical observers, have to think on a different level. The question is not, do these alignments have a physical effect, but do these alignments have a narrative effect? Human brains are pattern recognition machines, and we are hopelessly drawn to coincidences. It is a survival trait. Seeing connections, even where there are none, is hardwired into our psychology. Ancient cultures did it all the time, linking the appearance of a comet to a great battle, or the alignment of planets to the birth of a king. We are doing the same thing now, but in the language of pop science and internet speculation. The mainstream scientific view dismisses this as cosmic pareidolia, seeing patterns in random noise. And they are, from a purely physical standpoint, correct. But let's put on our tinfoil hats for just a moment and consider a more playful, more suspicious interpretation. If one were trying to manage the disclosure of a world-changing event, if one wanted to slowly acclimate a population to a new and potentially frightening reality, one might use exactly these kinds of tactics. One might leak a little information here, create a strange coincidence there, allowing the more fringe communities to connect the dots and build the narrative on their own. This allows the idea to seep into the public consciousness organically, championed by the crazies at first, until it becomes a familiar topic of conversation. Then, when the official announcement finally comes, the shock is cushioned. The public has already been playing with the idea for months. Are the excellent viewing conditions of Mercury and Ceres a deliberately timed piece of stagecraft in a slow-motion disclosure? Almost certainly not. But the very fact that people are making the connection is a phenomenon in itself. It shows a public that is hungry for meaning, that is desperate to believe that we are living in a time of cosmic significance. And this brings us to another, even stranger piece of theater: the Blue Origin flight of October 8th, 2025. As we discussed in a previous deep dive, this was a mission shrouded in an eerie and unnatural silence. A commercial, crewed spaceflight, an event that just a few years ago would have dominated the global news cycle, came and went with barely a whisper. There was none of the usual media fanfare, no viral in-cabin videos, no celebrity reactions. This was in stark contrast to a similar flight just 6 months prior, which had generated a firestorm of public interest and bizarre conspiracy theories about green screens and fake hatches. Which is more suspicious? The flight that everyone screams is fake, or the flight that everyone quietly agrees to ignore? The silence around the October 8th flight is deafening. It feels managed. It feels controlled. Why would a company built on public spectacle and excitement suddenly want to downplay one of its own successful missions? Why the radio silence? It creates a vacuum of information, a space where speculation naturally rushes in. Was it a routine flight? Or was something else going on? Was it a cover for a different kind of mission? A quiet deployment of observational technology? Or a quick, off-the-books retrieval of something? These are paranoid thoughts, of course, but they are thoughts that arise from a pattern of unnatural behavior, not from a void of evidence. When institutions and corporations start acting strangely, when they stop following their own predictable patterns of behavior, it is a red flag. The Blue Origin silence, when placed alongside the NASA shutdown, the convenient timing of the Mars life discovery, and the suspicious Quantico meeting, starts to look like another piece in a very large, very complex puzzle. It's as if all the major players are quietly moving their pieces on a chessboard that the public is not even aware exists. We are living in a time of anomalies, not just in the sky, but on the ground. And perhaps the greatest anomaly of all is the quiet, coordinated effort to pretend that nothing is happening. As we delve into this rabbit hole of anomalous data, convenient shutdowns, and strange fleets, we must not lose sight of the central, beating heart of this mystery: the origin of 3I Atlas's impossible breath. We've explored exotic ices, internal heat, and even the bizarre geometry of a focusing crater as potential natural explanations. But now, let's revisit the core argument and pick it apart with the focused and unapologetic rigor of a true detective. The official narrative rests on a single, fragile pillar: outgassing. And that pillar is about to crumble under the weight of simple physics. Let's grant them every one of their lucky coincidences. Let's say 3I Atlas has a perfectly structured binary nucleus, with a perfectly placed patch of supervolatile ice that just happens to be on a perfect 4-hour rotation, causing perfectly regular jets of gas to fire. Even if we grant them this entire chain of miraculous natural events, they still have to answer one question, and they have to do it without invoking magic. How do you produce 40 kilograms of water vapor per second without a visible coma? Let's get into the weeds of cometary science for a moment, because this is important. A coma, the glowing cloud of gas and dust that surrounds a comet's nucleus, is not an optional extra. It is the direct and unavoidable consequence of sublimation. When sunlight heats the ice on a comet's surface, that ice turns to gas. But that gas doesn't just vanish. It forms a temporary atmosphere around the nucleus. This gas cloud then expands outwards, and it is illuminated by the very same sunlight that created it, a phenomenon called fluorescence. The molecules in the gas absorb ultraviolet sunlight and then re-emit it as visible light. This is what makes a coma glow. A comet doesn't have a tail because it's a thing. It has a tail because it is actively, violently shedding its own substance into space, and that substance is being lit up like a celestial firework. The amount of gas required to produce 40 kilograms of water vapor per second is not a small amount. It is a torrent. It is an eruption. A coma produced by this level of activity should be vast, bright, and utterly unmistakable, even at the immense distances we're talking about. The fact that the Swift telescope detected the aftermath of this water, the hydroxyl cloud created when the water was broken down by UV light, but powerful visual telescopes cannot see the glowing source of the water, is a profound and glaring contradiction. How can you see the smoke without seeing the fire? The professional debunkers will try to give you an answer. They'll say, well, perhaps the dust-to-gas ratio is extremely low. They'll argue that our comets have a lot of dust mixed in with their ice. When the gas erupts, it carries this dust with it, and it's the dust, reflecting sunlight, that makes the coma so bright. If 3I Atlas were a very clean comet, made almost entirely of pure ice, with very little dust, its coma would be much fainter, made only of fluorescing gas. It's a plausible argument. But again, it would make 3I Atlas a completely new and unprecedented class of object. We have never seen a large, active comet that is this clean. Another lucky coincidence. And now, for all the brilliant minds in our chat and the new members who've just joined our spaceship of critical thought, welcome. We are at a critical juncture where we're separating hard science from wishful thinking. Your support for this independent platform allows us to have these conversations, and I'm honored to have you on the crew. Let's go further. What about the invisible gas theory we touched on? Could the comet be outgassing something that we simply can't see? Water, carbon dioxide, cyanide, all these molecules fluoresce and are detectable. If the main propellant was something like pure hydrogen or nitrogen gas, which are much harder to detect, then that might explain the lack of a visible coma. But that opens up another, even bigger can of worms. Where would a comet get vast reservoirs of pure hydrogen gas? It is the most volatile substance in the universe. It doesn't freeze into a stable ice, except at temperatures just a few degrees above absolute zero. For a comet to be made primarily of hydrogen ice is, according to our current understanding of planetary science, all but impossible. It would have had to form in the absolute coldest, densest part of an interstellar cloud, and it would have had to survive its journey without ever warming up. Once again, to save the natural explanation, we must invent an object that has never been seen and likely cannot exist. The simple, honest truth is this. A natural object cannot produce this much water vapor, at this distance, without producing a bright, glorious, and undeniably visible coma. The laws of physics are not optional. So what can produce thrust without a visible tail? An engine. Specifically, an engine that uses a propellant and a nozzle designed for efficiency, not for spectacle. Our own spacecraft engines are a perfect example. A chemical rocket produces a bright, visible plume because it's a messy, inefficient combustion process. But an ion engine, which uses electromagnetic fields to accelerate a small number of ions to incredible speeds, produces a faint, almost invisible blue glow. It is hyper-efficient, providing a gentle but constant thrust for an incredibly long time. If 3I Atlas were using an advanced propulsion system, perhaps a form of ion drive or a fusion torch, or something we can't even conceive of, it could easily generate the force needed for its 4-hour maneuvers without producing any visible exhaust. The water we are seeing, in this scenario, might not even be the propellant. It could be a completely unrelated exhaust product, a coolant, or the vented waste from a life support system. We are detecting the sewer pipe of the ship, while the clean, powerful engine remains invisible. This is the point where the case for a natural comet becomes, from a logical standpoint, deeply and fundamentally broken. It requires more miracles, more special pleadings, more never-before-seen exceptions than any rigorous scientist should be comfortable with. The artificial explanation, as extraordinary as it sounds, requires only one initial leap, that another intelligence exists and has mastered interstellar travel. After that one leap, everything else, the maneuvers, the lack of a tail, the harmonic signals, the weird chemistry, all fall into place as logical consequences of engineering. The principle of Occam's razor has never been clearer. We are faced with two choices. We can believe in a magical, tailless, clockwork, invisible gas-breathing, nickel-rich supercomet. Or we can believe in a ship. The former is a fantasy. The latter is just technology. In the next piece, we'll dive into a very human question that this entire mystery provokes. What if we're wrong? What is the real danger of speculating? And what is the greater danger of not speculating? As we stand on this precipice of extraordinary possibility, it is crucial to address the quiet fear that underlies much of the scientific community's resistance to the alien hypothesis. It's the fear of being wrong. What happens if we, the independent observers, the passionate speculators, the ones who are daring to say, "This looks like a ship," are wrong? What is the cost of our speculation? It's a fair question, and it's one that we must confront with honesty and intellectual rigor if we are to maintain our integrity as observers. The mainstream argument against speculation goes like this. By jumping to the alien conclusion, we undermine the slow, methodical process of science. We create a sensationalized narrative that is not supported by sufficient evidence. We risk a boy who cried wolf scenario. If we get this wrong, the public will be less likely to believe us the next time a truly profound anomaly appears. We could damage the credibility of the entire search for extraterrestrial intelligence, turning it into a field associated with crackpots and conspiracy theorists. In short, they argue that the potential harm to the reputation of science is too great a risk to take. This is a powerful and, on its surface, a very reasonable argument. The history of ufology is littered with cases that started with incredible claims and ended with mundane explanations. Weather balloons, lens flares, atmospheric phenomena. Being wrong in this field is common, and it can make the entire pursuit look foolish. And if I am standing here, telling you that this object exhibits all the signs of being a machine, and then in November, it sprouts a glorious cometary tail and starts behaving exactly like a normal, if slightly weird, comet, I will have been wrong. And there is a cost to that. My own credibility, and perhaps the trust this community has placed in me, will take a hit. I understand that completely. But now, let me ask the question that the mainstream scientific establishment refuses to ask. What is the cost of not speculating? What is the greater danger of remaining silent, of sticking to the safest explanation, even when it is actively contradicted by the evidence? I believe the danger of silence is infinitely greater. The history of science is not a story of cautious consensus. It is a story of brave, imaginative leaps. It is the story of Galileo daring to say the earth moves, of Darwin daring to say that life evolves, of Einstein daring to say that time is not constant. Every single great breakthrough in human understanding began as a radical, speculative hypothesis that was mocked by the establishment of its time. The greatest risk to scientific progress is not being wrong. It is the institutional cowardice that prevents us from even asking the right questions. By refusing to publicly and seriously entertain the artificial hypothesis for 3I Atlas, the scientific establishment is failing in its primary duty, which is not to be right, but to explore every possible explanation that fits the facts. Their silence, their dogmatic insistence on a natural explanation that is becoming more fantastical by the day, is a greater betrayal of the scientific method than any bold speculation could ever be. They are not protecting science. They are protecting their own comfort and their own paradigms. and welcome to all the brave new thinkers who have just joined our community. You are here because you understand that asking, "What if?" is not an act of foolishness, it is an act of courage. Your support for this channel is a direct vote for that kind of fearless curiosity. Furthermore, there is a profound practical danger to their silence. Let's return to the dark forest theory. If we are in the presence of an advanced probe from a potentially hostile or indifferent civilization, then to willfully ignore that possibility, to dismiss it as conspiracy, is an act of breathtaking recklessness. The precautionary principle would suggest that any object exhibiting controlled, non-natural behavior should be treated as a matter of global security until it is proven to be benign. But by insisting it's just a weird comet, the official channels are lulling the world into a state of complacency. They are failing to prepare us for a possibility that, however remote, has stakes that are unthinkably high. The cost of being wrong about a comet is a few bruised scientific egos. The cost of being wrong about a first contact scenario is existential. And finally, what is the cost to the human spirit of this enforced silence? We are a species born of wonder. We look at the stars and we dream. For centuries, the question, "Are we alone?" has been the most powerful and unifying question we have. This moment, with 3i Atlas, is the closest we have ever come to getting a potential answer. To rob humanity of the collective experience of this mystery, of the shared global conversation, of the thrill and the awe of this potential discovery, by hiding the data and insisting on a boring, inadequate explanation, is a kind of cultural crime. It is the theft of wonder. So, yes, there is a risk in being wrong. But I will take that risk every single time over the alternative. I would rather be the passionate observer who shouts, "Look, something incredible is happening," and is later proven to be mistaken, than to be the cautious bureaucrat who whispers, "There's nothing to see here," while the most important event in human history sails silently by. We are here to ask the big questions. That is our purpose. In the end, the greater foolishness does not lie in contemplating the extraordinary. It lies in refusing to. In the next part, we will discuss the human drive for discovery and how this single mysterious object is reawakening the spirit of exploration that is humanity's greatest asset. As we navigate this incredible unfolding story, day by day, anomaly by anomaly, it's not just the cosmos we're observing. We are also, in a very real sense, observing ourselves. A mystery of this magnitude doesn't just happen out there in the cold vacuum of space. It happens in here, in our minds, in our emotions, in our collective human psyche. The psychological impact of this event is as profound and as worthy of study as the object's trajectory itself. And for us, as a community of observers, maintaining our own mental and emotional balance is the most important mission of all. The human brain is a pattern-seeking machine. It is what we do best. We look at the chaos of the world, and we search for order, for meaning, for a story that makes sense. When faced with a profound unknown like 3i Atlas, this instinct goes into overdrive. For some, the response is an immediate and overwhelming excitement. The patterns we see, the harmonics, the lack of a tail, the coincidences all click into place to form a narrative of alien visitation that is thrilling and world-changing. This excitement is a beautiful and powerful thing. It's the fuel of our curiosity. But it also comes with a danger. The danger of wanting the story to be true so badly that we stop questioning it. It's the moment we trade our detective's magnifying glass for a believer's banner. On the other side of the spectrum, the response is fear. The unknown is inherently frightening. An object that is not a comet, that is maneuvering with purpose, and that comes from an unknown intelligence, can trigger our most primal survival instincts. What are their intentions? Are we in danger? Is this the end of the world as we know it? You'll see this fear manifesting online in doomsday predictions, in panic, and in a desperate search for reassurance from authority figures, even if that reassurance is based on a lie. Fear, just like unchecked belief, is a blinder. It shuts down critical thinking and replaces it with a desperate need for safety. Our job, as the crew of this Dysonian spaceship, is to navigate the treacherous waters between these two extremes. We must sail the narrow channel between blind faith and paralyzing fear. Our guiding star must be the evidence itself. Our methodology must be a passionate but disciplined agnosticism. We can be thrilled by the possibility of a discovery, while still demanding the rigorous proof. We can be aware of potential risks, without succumbing to irrational panic. This is a tightrope walk, and it requires a constant and conscious effort to stay balanced. One of the best ways to do this is to embrace the what if as a playground, not a battlefield. Here, we can entertain the most extraordinary ideas, ghost probes, warning sentinels, cosmic gardeners, but we do so with a spirit of intellectual play. We are exploring the implications of a hypothesis, not declaring it as an infallible truth. This allows our minds to be flexible, to test out different narratives, and to see which ones fit the data best, all without getting emotionally locked into a single outcome. When you treat it like a detective game, a grand cosmic whodunit, it becomes an empowering exercise in reason rather than an anxiety-inducing wait for judgment. A huge and heartfelt welcome to our newest Ultra Explorers and Super Explorers. Your incredible support is the foundation of this independent platform. By joining our highest tiers, you're not just watching, you are a core partner in this mission to keep asking the big, uncomfortable, and awe-inspiring questions. Thank you, from the bottom of my heart. It's also crucial to manage our own information diet. In the coming weeks, as public interest spikes, the amount of noise, disinformation, and fear-mongering will explode. If you spend all day scrolling through a feed of apocalyptic predictions and blurry fake videos, your mental state will suffer. You have to be the gatekeeper of your own mind. Get your information from credible, primary sources, whenever possible, the scientific papers, the press releases from major observatories, the analyses from trusted figures like Loeb, and get it from communities like this one, where the focus is on evidence-based discussion, not on panic. Turn off the noise. Focus on the signal. And let's talk about patience. This story is not a 2-hour movie. It's a long-form series, and the episodes are not released on our schedule. There will be long periods of frustrating silence where no new data is available. There will be setbacks. There will be confusing and contradictory information. The urge to get the final answer right now is immense, but it is an urge we have to resist. Real discovery takes time. The scientific process, when it's done right, is slow and methodical. Our impatience does not speed up the photons on their journey from 3I Atlas to our telescopes. We have to learn to live with the mystery, to find a sense of peace in the not knowing. In a way, this event is a global-scale meditation on patience. Finally, remember the human connection. The most beautiful thing about this entire saga is that it is a shared experience. We are not facing this mystery alone. We are facing it together. Millions of us across the planet, all looking up at the same sky. The connections we are building right here, in this community, are real. We are sharing data, theories, excitement, and a sense of wonder. This community is an antidote to the fear and isolation that can come with confronting such a massive unknown. We are a crew. We have each other's backs. Whatever happens, we will observe it together. In the next piece, we will begin to bring our journey to a close, summing up the core arguments and reflecting on what it truly means to be an observer in this unique and incredible moment in human history. As we begin to bring this deep dive into its final phase, let's consolidate the case file. Let's lay out all the evidence we've meticulously gathered and present it as if we were detectives standing before a grand jury of our own collective intellect. The question on the table is this: is the behavior of 3I Atlas explainable by natural cometary phenomena, or does the weight of the evidence demand we seriously consider the hypothesis of an artificial origin? Let's review the prosecution's case against the boring rock theory, point by point. Exhibit A: the clockwork maneuvers. This is our smoking gun. The new paper by Medvedev and Pavlov is not a fringe theory. It is a rigorous scientific analysis, concluding that 3I Atlas exhibits a statistically significant periodic positional shift every 4 hours. An object in space does not simply wobble for no reason. This is evidence of a non-gravitational force acting on the object. The natural explanation is that this is caused by jets of outgassing from a rotating nucleus. But for this to be so perfectly regular, so harmonically tuned to the object's main 16-hour rotation, it would require a comet with a geological structure of almost unbelievable symmetry. 4 equally powerful vents, spaced at perfect 90-degree intervals. It's a classic case where the natural explanation requires a miracle of cosmic coincidence. The artificial explanation? 4 symmetrically placed thrusters. Simple, logical, efficient engineering. Exhibit B: the rhythmic flashes. The same study confirmed a periodic brightening of the object every 2 hours, a perfect second harmonic of the positional shift. The natural explanation is that this is sunlight glinting off a highly reflective patch of ice on a tumbling binary nucleus. Again, this requires an incredible amount of luck in the object's composition and orientation. The artificial explanation is far cleaner: a communication signal, a navigational beacon, or the regular rotation of solar panels. What they see as a chaotic tumble of space potatoes, we see as a potential organized system. Exhibit C: the missing tail. This is the evidence that hangs the entire outgassing theory out to dry. Every argument the natural model makes for the maneuvers and flashes that they are caused by sublimating ice absolutely requires the production of a massive, visible coma and tail. An object powerful enough to use its own gas as a propulsion system should be one of the most spectacularly beautiful comets we've ever seen. But it has no tail. It has no coma. The ESA images and all other observations are unequivocal on this point. To save their theory, they must invent a stealth comet that outgasses invisibly, a concept that has never been observed and has no scientific precedent. It is a fantasy. A tailless object that is actively thrusting is, by definition, a ship. A special welcome and a huge round of applause for our new Dawsonian explorers who have just joined us. By supporting this channel, you are casting a vote for a kind of curiosity that isn't afraid to ask the big, uncomfortable, and awe-inspiring questions. It's an honor to have you with us. Exhibit D: the precedent of Oumuamua. This isn't the first time we've played this game. In 2017, Oumuamua, our first interstellar visitor, showed the exact same combination of anomalies: non-gravitational acceleration and a complete lack of a cometary tail. At the time, it was dismissed as a one-off weirdo. But now we have a second one, and it's even weirder. In science, as in life, when a 1-in-a-million anomaly happens twice in a row, it's no longer an anomaly. It is a pattern. And the pattern is this: objects are arriving from interstellar space that do not behave like the rocks we were told to expect. Exhibit E: the Great Wall of Coincidence. As we've detailed, the scientific anomalies are not happening in a vacuum. They are surrounded by a suspicious cloud of political and bureaucratic maneuvering. The perfectly timed shutdown being used to withhold the best images, the preemptive soft disclosure of life on Mars, the secret meeting of astronomers and intelligence officials near a SETI-focused observatory, the restructuring of NASA into an intelligence umbrella agency, and the blatant, provable lie about the Psyche probe's September 4th imaging opportunity. To believe all of this is just a series of unrelated accidents is, frankly, naive. It is a pattern of behavior consistent with a group of people who know they are sitting on a world-changing secret and are desperately trying to control the narrative. So, when we lay it all out, what do we have? The case for a natural object rests on a chain of increasingly improbable special pleadings. You have to believe in a magic, invisible-tailed, perfectly symmetrical, harmonically tuned, tumbling, double-headed space potato. The case for an artificial object, on the other hand, is simple. It is a machine, behaving like a machine. According to the principle of Occam's razor, the simplest explanation that fits all the facts is the most likely to be true. And in this case, the simplest explanation is no longer, it's a weird rock. It's not a rock at all. This doesn't mean the case is closed. We are detectives, not judges. We must continue to demand more evidence, to remain open to new data that could change the picture entirely. But as of this moment, based on the evidence we do have, the hypothesis of an artificial origin is no longer a fringe conspiracy theory. It is a sober, logical, and scientifically sound conclusion that deserves to be the leading hypothesis in this investigation. In the next few pieces, we'll turn from the evidence to the future, asking what this all means for humanity, for our science, and for our place in the cosmos. With the evidence laid bare, and the leading hypothesis pointing towards a conclusion of artificial origin, we are compelled to ask a question that feels both thrilling and deeply humbling. What kind of civilization could build such a thing? To contemplate the creators of 3I Atlas is to take a journey into the realm of truly advanced, perhaps even ancient, intelligence. It's a thought experiment that not only stretches our imagination, but also serves as a profound mirror reflecting our own technological infancy and our potential future. The Kardashev scale, a concept proposed by Soviet astronomer Nikolai Kardashev, is a useful framework here. He theorized that civilizations could be categorized based on the amount of energy they could harness. A Type I civilization is one that can utilize all the energy available on its home planet. By this measure, humanity is not even a Type I civilization yet. We're somewhere around a Type 0.7, still largely dependent on the fossilized sunlight of our planet's past. A Type II civilization would be one that can harness the total energy output of its host star. They might build a Dyson sphere or a similar megastructure to capture their star's entire luminosity. A Type III civilization would be one that can command the energy of an entire galaxy. Now, let's consider the creators of 3I Atlas, a civilization capable of launching interstellar probes that can last for millions of years, that are fully autonomous, and that possess an energy source we can only dream of is, by definition, vastly beyond Type I. They would, at the very least, be a mature Type II civilization, having mastered their own star system and begun to expand their reach into the cosmos. More likely, given the time it would take to develop and launch such probes across the galaxy, we could be looking at the work of a Type III civilization. A civilization so old, so powerful, and so widespread that the energy of entire galaxies is their playground. The implications of this are staggering. To a Type III civilization, the laws of physics are not just things to be discovered, they are tools to be wielded. They would have mastered energy, matter, and perhaps even space-time itself. Building a self-healing, autonomously intelligent starship would be no more difficult for them than building a bicycle is for us. They would likely not be biological beings in the fragile, carbon-based sense that we are. Over millions of years, they may have transitioned to a post-biological existence, their consciousness uploaded into vast, computational substrates, or merged into a collective intelligence. They might be beings of pure information or energy, their physical forms as alien to us as our bodies would be to a single-celled amoeba. Such a civilization would not think in terms of years, or centuries, or even millennia. Their projects would unfold on geological and cosmic timescales. A mission to explore the galaxy with a fleet of von Neumann probes would not be a short-term goal. It would be a multi-million-year endeavor, a patient and systematic project of mapping and cataloging. To them, the 50,000 years it might take for a probe to travel between stars would be a trivial amount of time. They would not be impatient for results. They would be engaged in a process as steady and as persistent as the evolution of a galaxy itself. And now, a special shout-out and a heartfelt welcome to all our new explorers who have jumped aboard this mission tonight. By supporting this channel, you are casting a vote for a kind of curiosity that isn't afraid to ask the big, uncomfortable, and awe-inspiring questions. It's an honor to have you with us. So, if we are dealing with a civilization of this magnitude, the dark forest theory we discussed earlier takes on an even more chilling light. A Type 3 civilization with access to galactic-scale energy would also have access to galactic-scale weaponry. They would view the universe with a caution born of immense age and experience. They would know, from perhaps millions of years of observation, that the universe is not always a friendly place. Their silence would not be a sign of shyness. It would be a sign of supreme and ruthless intelligence. A civilization that ancient would not take chances. Their reconnaissance probes, like 3I Atlas, would be designed for stealth and efficiency, gathering data without revealing their own capabilities or intentions. The decision of whether to eliminate a potential rising competitor like us would be a cold, strategic calculation, not an emotional one. On the other hand, an equally compelling argument can be made that a civilization that has survived for millions of years, that has overcome the existential threats of war, of environmental collapse, of its own technological adolescence, must have developed a profound sense of wisdom and empathy. To reach Type 3 status would require a level of cooperation and long-term planning that is almost unimaginable to our fractious, short-sighted species. Such a civilization might be less like a hunter and more like a gardener. They might see the emergence of young, intelligent life, like ours, not as a threat, but as a precious and rare event to be nurtured and protected from a distance. Their silence could be the silence of a patient guardian, watching from afar, allowing us to make our own mistakes and find our own way. The periodic shifts and flashes of 3I Atlas might be an entirely internal process, deliberately shielded from sending any easily decipherable hello message so as not to contaminate our cultural development. In either scenario, whether hunter or gardener, we are in the presence of a power that is, for all intents and purposes, awe-inspiring from our perspective. The confirmation of such an object would be the most profound religious, philosophical, and scientific event in human history. It would force us to redefine our understanding of our own potential and our own place in the cosmos. It would be a mirror showing us a possible future, a future of immense technological power and, hopefully, the wisdom to use it. In the next part, we'll continue this thought experiment, exploring what technologies we might be able to reverse engineer just by observing 3I Atlas from afar. Could its mere presence be a key that unlocks our own technological evolution? If we are in the presence of a technology millions of years ahead of our own, the question isn't just who built it, but what can we learn from it? Even without making direct contact, even without capturing the object, the very act of observing 3I Atlas from a distance could be the single greatest scientific windfall in human history. The object is a traveling masterclass in advanced physics, and the final exam is scheduled for December. Humanity needs to be taking notes. This could be our Rosetta Stone moment for interstellar engineering. Let's start with the most obvious lesson: propulsion. We've established that the periodic 4-hour shifts in its position are evidence of some form of thrust. For decades, Our own theoretical physicists have dreamed of advanced propulsion systems that go beyond the brute force of chemical rockets. We've imagined fusion drives, antimatter engines, and even drives that warp space-time. 3. IATLAS is a living, or at least functioning, demonstration that one of these, or something even more exotic, is possible. By carefully analyzing the precise nature of its positional shifts, how fast, how smooth, in what direction we might be able to reverse engineer the principles behind its engine. Is it a gentle, continuous thrust, or a series of short, sharp burns? Is there any detectable energy signature associated with the maneuvers, like a burst of gamma rays or neutrinos? The how it moves could tell us more about advanced propulsion than a century of chalkboard equations. Next, consider its energy source. As we've discussed, to power a craft for a million-year journey and still have enough energy to maneuver, you need something extraordinary. If we can detect any form of energy leakage from the object waste heat, radiation, a specific particle signature, it could be the key to unlocking a new era in our own energy production. If we were to find, for example, that it's leaking helium-3, that would be a strong clue pointing towards a hyper-efficient fusion reactor. If it's absolutely cold and shows no thermal signature, that might point towards something even more incredible, like the harnessing of zero-point vacuum energy. The implications would be world-changing. An energy source that is clean, compact, and lasts for millennia would solve our own planet's energy crisis overnight and pave the way for our own first steps into interstellar space. We wouldn't just be getting a science lesson. We would be getting the blueprint for our own future. Then there is the matter of its communication system. Those rhythmic, 2-hour flashes of brightness are, in the artificial hypothesis, a signal. Our current approach to SETI is to listen for radio waves. But if 3i Atlas is communicating via pulsed, coherent light, essentially a galactic-scale laser communication system, it would confirm that this is a viable, and perhaps even preferred, method for interstellar messaging. By analyzing the properties of these light pulses, their frequency, their polarization, their duration, we might be able to start deciphering the very structure of the message. We might not understand the language, but we could learn the syntax. Are they using a binary code, a series of prime numbers? Even if we can't read the letter, just seeing the envelope would be a revolution. And for all the fantastic new explorers and longtime members here tonight, you are part of this process. The support from our Dysonian power crew is what allows me the time and resources to not just report on this, but to dig deep and analyze it with the rigor it deserves. A heartfelt thank you for being the foundation of this community. Let's not forget the object's physical properties, its materials. How does it survive a million-year journey through the radiation and micrometeoroids of interstellar space? A detailed spectral analysis of its surface could reveal the presence of exotic alloys or metamaterials with properties of self-healing or extreme durability. If we were to find spectral lines that correspond to no known natural element, it would be evidence of manufactured transuranic materials, a definitive made-by stamp from its creators. Even the way the object reflects light could tell us about its surface texture and properties. Is it a smooth, polished hull, or is it a complex, fractal-like surface designed to dissipate heat or radiation? And finally, there's the most mind-bending possibility of all, observing its interaction with space-time. An object this advanced, particularly if it's using some form of gravitational or space-time warping drive, might produce subtle, localized distortions in the fabric of space around it. These would be incredibly difficult to detect, but not impossible. Future generations of our own gravitational wave detectors might be able to spot tiny, anomalous ripples as the object maneuvers. If we ever detected that a controlled, localized warping of space-time, it would prove that the dream of warp drive is not science fiction. It would mean that mastering gravity itself is possible. It would be the single greatest discovery in the history of physics, handed to us by a silent, passing teacher. This is why the lack of a concerted, global, and transparent observation campaign is so infuriating. We are potentially letting the greatest scientific and technological opportunity in human history slip through our fingers because of bureaucracy, secrecy, and a fear of confronting the truth. Every photon from this object, every gravitational ripple, every potential particle it might be emitting is a page from a textbook that is a million years ahead of our own. We should not just be looking at it. We should be studying it with a frantic and joyful intensity. The secrets to our own technological advancement might be encoded in its very existence. In the next part, as we draw our investigation to a close, we will reflect on what it means to be a human observer at this potential turning point in our history. As we approach the final moments of our deep and sprawling investigation tonight, our journey naturally pivots from the object itself, its science, its behavior, its origins, to the quiet, profound, and intensely personal space it occupies in our own minds. We are a species defined by our stories. We tell stories about our past to understand who we are. We tell stories about our future to give ourselves hope. And we tell stories about the cosmos to find our place within it. The story of 3I Atlas, whatever its final chapter may be, has already become one of the most powerful and transformative narratives of our time. And what it is teaching us about ourselves is as important as what it might teach us about the universe. For the first time in a generation, millions of people around the world are united in looking up at the sky and asking the same question. In an age that can feel so fractured, so cynical, so saturated with digital noise and fleeting distractions, this shared mystery has reawakened a sense of collective wonder that many of us thought was lost. You can feel it right here, in this community. People from every continent, every walk of life, every belief system are gathered in this digital space, sharing data, debating theories, and expressing a shared, almost childlike excitement for discovery. This is a rare and beautiful thing. 3I Atlas has reminded us that despite our differences, we are all inhabitants of the same small planet, looking out at the same immense and mysterious cosmos. This event is also a powerful exercise in humility. For a species that has prided itself on its intellect, that has mapped the human genome, split the atom, and sent robots to other worlds, the presence of a technology potentially millions of years beyond our own is a profound and necessary reality check. It reminds us that we do not have all the answers. It shows us that our science, as brilliant as it is still just a flickering candle in a vast, dark cathedral of knowledge. To accept that we might be primitives in the galactic scheme of things is not a demotion, it is an act of wisdom. It is the beginning of a new chapter of learning, a chapter where we are no longer the teachers, but the students. This mystery is also forcing a long overdue reckoning with the culture of science itself. The story of 3I Atlas has starkly illuminated the conflict between pure, evidence-based curiosity and the rigid, career-protecting dogma of institutional science. Figures like Avi Loeb have become champions for a more courageous and open-minded approach, while the official silence and contrived explanations from the establishment have shown just how resistant to new paradigms our institutions can be. This isn't an attack on science. It is a defense of the scientific method itself. It is a demand that we follow the evidence, even when it leads us to uncomfortable or extraordinary places. This moment could be a catalyst for a renaissance in science, a return to the bold, speculative, and wonder-driven spirit of its greatest pioneers. Now, for one of the last times tonight, a massive and heartfelt welcome to every single new member who has joined our crew on this incredible journey. This isn't just a channel, it's a mission. And if you believe in the power of independent, fearless curiosity and want to support it, I humbly invite you to click that like button and subscribe. You're not just a number, you're part of the team. Thank you. On a personal level, this journey is a meditation on what it means to be an observer. We are inundated with information, but we are starving for truth. We are told what to think, how to feel, and what to believe. To consciously choose to be an observer is an act of rebellion. It is the act of setting aside the pre-packaged narratives and looking at the raw data for yourself. It is the act of trusting your own critical mind, of asking your own questions, and of having the courage to live with uncertainty. This community is a testament to that spirit. You are not here to be told what to believe. You are here to be a part of the investigation. You are here to think. And in the end, that may be the greatest gift that 3i Atlas has given us, long before we even know what it is. It has given us a reason to think, to wonder, and to talk to each other about the biggest questions imaginable. It has pulled our gaze away from the ground and lifted it, once again, to the stars. It has reminded us that the universe is not a solved equation. It is a living, breathing, and endlessly surprising mystery. And to be alive in a time when a piece of that mystery is sailing right through our own backyard is a privilege of almost unimaginable proportions. In the final part of our broadcast tonight, we will bring our journey to its quiet conclusion, summarizing our findings and leaving us with a final and contemplative thought to carry with us into the week ahead as we continue our collective watch of the skies. This is a story that is far from over. In many ways, it has only just begun. So, here we are, at the end of this deep dive, but at the very beginning of what may be the most important story in human history. We have followed the evidence. We have connected the dots. We have stripped away the layers of denial and deception to stare at the core of this profound and thrilling mystery. And what are we left with? We are left with a case that is as compelling as it is incomplete, as electrifying as it is unanswered. Let us summarize the file on 3i Atlas one last time. We have Exhibit A, the confirmed, clockwork-like positional shifts every 4 hours, a harmonic signature of controlled maneuver. We have Exhibit B, the rhythmic, 2-hour flashes of light, a periodic signal harmonically locked to the object's movements. We have Exhibit C, the absolute, undeniable absence of a cometary tail, a fact that single-handedly cripples the entire natural outgassing theory. We have Exhibit D, the chilling precedent of Oumuamua, a previous interstellar visitor with a near-identical set of anomalies. We have Exhibit E, the mountain of suspicious coincidences and the blatant, provable lie of a coordinated information blackout by the world's most powerful institutions. The theory that this is a natural object no longer holds. It is a dead theory, propped up only by dogma and a desperate, unscientific hope that the universe is as boring as the establishment wants it to be. The leading hypothesis, the one that fits all the available facts with a clean and simple elegance, is that 3i Atlas is an artifact of non-human, extraterrestrial intelligence. It is a probe, a machine, a ship. What this means for us, for our future, for our place in the cosmos, is a question so immense it almost feels too big to ask. But we must ask it. We are standing on the threshold of a new reality. The coming weeks and months, particularly as we approach the close flyby on December 16th, will be a crucible. The pressure for truth will become immense, and we, this global community of observers, will be on the front lines, watching, analyzing, and demanding the facts. This is not a time for fear. This is a time for awe. It is a time for unity, and it is a time for a profound and joyous curiosity. And now, my friends, a final, heartfelt thank you. Thank you for joining me on this wild and wonderful journey. Thank you for your energy, your intelligence, your support, and your insatiable curiosity. This channel is not me, it is us. It is a living, breathing testament to the power of independent thought and collective passion. You are the reason we can do this. You are the force that drives this investigation forward. If you believe in this mission and haven't yet joined the crew, I humbly ask you one last time to hit that like button and subscribe. It's the simplest way to say, the search must continue. Whatever the final truth of 3i at last turns out to be, it has already given us a gift. It has reawakened our collective sense of wonder. It has reminded us that the universe is still full of breathtaking mysteries, and that the greatest discoveries may be just around the corner. We live in a privileged time, a moment when our technology is finally catching up to our oldest dreams. We are the generation that may get the answer. So, stay curious, stay observant, stay skeptical of anyone who tells you there's nothing to be concerned about. Keep watching the skies, and never, ever let anyone tell you that it's just a rock. Because right now, the evidence is pointing to something far, far more interesting. Thank you for being here. This has been the Sleepy Observer. I will see you on the next one. Clear skies.